Hi, my name is Bhakti Lienage. This is the group presentation 1 for Data 670 Data Analytics Practicum. In this presentation, I'll be talking about my project, how I approach the problem. Before that, I will go through the agenda. First, I will briefly talk about the business background, what this problem is about, and then I will talk about the project objectives, project scope and the deliverables, data description, relationships and data loading. Finally, I'll be talking about predictors and what type of targets I'm looking at. And at the end, I'll be talking about next steps. So to give you a business background, Skyline Business Travels provide concierge service for business travelers. In highly competitive market, they are always looking for ways to be competitive and provide added value to their corporate customers. In identifying the impact of weather-related delays affecting their customers' travel plans, the company is investigating ways to improve the flight booking experience more streamlined and customer-centric by including data-driven decision-making. So the project objectives. Before I go into project objectives, I would like to give some facts about what what drives this problem, and those numbers will give you a really good indication why we should be focusing on this kind of a problem. So according to FAA Consumer Report in 2017, airline careers caused 20.2 million minutes of delays in 2007. And according to the same report, industry lost 17.5 million minutes due to weather-related events, costing passengers billions of dollars. So in planning their product, the company came up with the idea of using predictive analytics to help customers best select their travel based on the likelihood of delays due to the departure airport and destination airport weather conditions. So let's talk about project scope. So I have divided this slide into two sections, in scope and out of scope. Due to the time constraints, I would not be able to consider all the causes for airline delays, but in this case I will just focus on airline delays due to weather related activities. So in scope area, I will first explore the relationship weather and the flight delays, explore the impact of weather on operations of 10 busiest airports around the country, identify the top 10 major airports persistently impacted by weather conditions. There are some airports that are actually severely affected by weather, and some of the airports are not affected by the weather, especially in Midwest and Northeast airports are affected by weather conditions. So the airports around those areas will have impact on the flight delays due to weather conditions. And finally, develop and operationalize data analytics solution to predict flight delays for a given airport code and local weather conditions pertinent to that airport. In this project, I will not be focusing on predicting the delays in minutes. I cannot give you a quantitative analysis on the airline delays due to the complexity of the problem. In this case, I will only focus on binary value, whether a flight will be delayed or not. And the other out of scope area is non-weather related delays. Flights are delayed due to so many various reasons like flight operations and so on. But in this case, I don't have enough data on those areas to make the flight delay assessment based on non-weather related data. Therefore, I will just focus on weather related data. Next, the project deliverables. The first deliverable is a machine learning model, that is a predictive analytics model to help customers best select their travels based on the likelihood of delays due to departure airport and the destination airport weather conditions. Then the second deliverable is operationalization of the model. So no model is good if you cannot have it in a production system. So that's the second part. The predictive model will be deployed to a web application that will serve as the customer booking portal. The system will consume 10-day weather forecast from third-party weather data service to allow the customer to be informed about the weather-related flight delays 10 days in advance. Let's talk about the data. I have got 3 data sets. The first data set is flight delays with airport codes. This dataset is a product of Bureau of Transportation Statistics that provides the details of flight delays at a given airport. This dataset contains 2.7 million observations with 20 attributes, and the data was collected between 1st of April 2013 and 31st of October 2013. The second dataset is airport weather with airport code. So in this dataset, I have 60 different airports with hourly weather recordings, and the data is formatted as CSV file. This dataset contains hourly weather data like temperature, dew point, barometric pressure, and so on. This dataset contains 406,000 observations ranging from 1st of April 2013 to 31st of October 2013. And the final dataset is the airport location and its geographical data with the airport code. This dataset will be used to display the delays on a geographical map. In this slide, I'll be talking about extract, transformation, and loading data. So as I mentioned in the previous slide, I have 3 datasets, all in CSV format. And the CSV format data is the number of observations are too big to be loaded into my R Studio. Therefore, what I did, loaded all the data into a DB or the Bluemix data platform. I created 3 databases for each CSV files, and if you can remember, in my previous slide I mentioned about the data points collected hourly. So the data is actually collected on at minutes, but due to the large number of data points, I have normalized all the data to be recorded as hourly. So that's the transformation that I do during the loading process and the ETL process. I do the transformation. I transform the hourly recording into just hourly numbers and create a flight fact table which contains all the data, including the data for origin, the temperature and the weather data for origin airport, and the weather data for destination airport. This is the data relationship. So I have the flight table which contains the year, month, day of month, origin airport, and the origin departure hour, day of week, destination destination arrival time, and so on. And the weather data table contains the same year, month, day, airport, and it contains other weather related data. So let's investigate the predictors and targets. In this dataset, I aggregated all the data into one fact table, and the fact table has year, month, day of month, and so on. And also it contains the airline carrier, the original airport, departure hour, destination airport, arrival time in hour, and also the weather information related to the original airport, which contains origin temperature in Celsius, origin dew point in Celsius, humidity, wind speed, wind direction, and the pressure, sea level pressure, and hourly precipitation. Similarly, I included the same parameters, same weather conditions for the destination time zone, destination temperature, dew point, humidity, and so on. This dataset will serve as the fact table for my predictive model. Let's see about the targets. I have identified 3 targets. According to FAA definitions, any flight departs after 15 minutes from its scheduled time or arrive after 15 minutes of its scheduled arrive time are considered to be delayed. So I follow the same definition from the dataset. So I have created a binary value, which one indicating whether the flight was delayed or not. If the departure is more than 15 minutes delayed, it is considered 1, which means it is delayed. And the same goes to arrivals. If the flight arrival is delayed more than 15 minutes, it's considered as the flight is late or delayed. So in this case, I use the binary value 1 to indicate whether the flight is delayed or not. The third target is the cancelled. So some flights are actually get cancelled. So in this case, I use binary value 1 to indicate whether the flight was cancelled or not. Let's talk about the machine learning aspect of this project. I mainly use the supervised learning techniques because I have the predictors and the target values, the historical values. So this is so the supervised models would be the best for this kind of a problem. In this case, the training data will be used. For this project, it's the departure and arrival data, including weather data. And the next step, I would be doing some pre-processing. Some exploration is done to determine which airports are most vulnerable for airline weather-related delays. And from that, I will extract most influential features or the predictors for the problem, and then use those predictors to develop the model. In this case, I will be using some of the supervised learning models, which I will be talking in the next slide. So once I create the model and choose the best model, it will be deployed into a production system. And the production system, we will give new data, and we will perform the same data preparation steps that we followed in the training step, which will result in a feature vector. And the feature vector is pushed into the predicted the model, and then the model will give us the information, the assessment of whether a flight was delayed or not. In this project, I have considered 2 different types of algorithms. The first type is tree-based. So there are multiple tree-based models like decision trees, decision forest, XGBoost, and so on. So I'll be using multiple multiple algorithms, tree-based algorithms in to determine the flight delays, as well as I will be using logistic regression models to predict the binary value. Once I do that, I will compare the performance of each model and then choose the best model out of all these models. So the next steps are training the models, compare the performance of the models, deploy the selected model into the production system, and I will also be integrating the production model with the web application using our Shiny apps. That concludes my presentation for the group. Thank you very much.